Hi friends, today I am going to introduce you about quantum numbers. We have four types of quantum numbers. They are principal quantum number, angular momentum quantum number, magnetic quantum number and spin quantum number. This principal quantum number represents the energy level of an atom. It is represented by the letter n and it has values starting from 1, 2 and up to so on. Moving to the next, angular momentum quantum number. This represents the shape of an orbital, whether it is a sphere or dumbbell shape or double dumbbell shape. It is represented by the letter L and it has values starting from 0 and the final value is n minus 1. And moving to magnetic quantum number, it represents the orientation of an atomic orbital in a space. It has integer values starting from negative along with positive. And spin quantum number, this represents the spin of an electron in an atom. It has only two values, either plus of or minus of. Now I am going to tell you about how can we write the quantum numbers for a given element. That means if 1 is 2, how can we write the values of these four quantum numbers? And we have four quantum numbers, that is n, l, ml and ms. Here n value, we can easily recognize that the constant number given is the n value. Here the n value is 1. And L value, how can we write L value? Means if L equal to 0, it represents the s orbitals. We already know that. If L equal to 1, it represents p orbital. Like that, here the given orbital is s orbitals. For s orbital, the L value is 0. And moving to ml value, I already told that ml value includes both positive and negative. How can we write? S orbital can accommodate 2 electrons. That means it has only one value, that is 0. Here 2 electrons are there. We are going to accommodate those 2 electrons in the orbital like this. How can we determine whether it is plus half or minus half? Means if the electrons is in upward direction, that is represents plus half. When it is in downward direction, it represents minus half. ml value, we are going to write ml value 0 because 2 electrons are in same orbital. And ms value minus half. Why? Because means lost electron is in downward direction. Like this, we are going to write the four values of four quantum numbers for the given element. And going to p orbital, this one, n value, L value, ml and ms. Here the constant is 3, so the n is 3. And L value, how can we represent L value? That means that is p orbital they are given. The value of L for p orbital is 1. And then moving to magnetic quantum number, here p orbital can accommodate maximum of 6 in it. How can we represent these? Means like this. Here 0, minus 1 and plus 1. Here 5 are there, 5 electrons are there. That means according to Hund's rule, all the electrons should be filled in all the boxes like this. 1, 2, 3, 4 and last one 5. Here the last electron is filled in this one, so the ml value becomes 0. And how can we determine whether it is plus or minus half? Means the final electron is in downward direction, so it represents always minus half. And for d orbital, how I am going to write? Means n equal to and ms. Here n value, the constant 4. L value, they have given the orbital d. For d orbital, the L value is 2. And Mn value, how can we represent? Means we have 5 like this. It can accommodate maximum of 10 electrons in it, like this. And we are going to write those values here. And they have given 9 electrons. How can we write those 9 electrons? 1, 2, 3, 4, 5, 6, 7, 8 and finally 9 here. The Ml value is 1. And Ms value, how can we determine? That means that is in downward direction. So Ms value is minus half. And for f orbital, how we are going to write? Means n value 4, L value is, they have given f orbital. For f orbital, the L value is 3 and Ml value. F orbital can accommodate maximum of 14 electrons in it. So we are going to write 7 like this. And the middle one is here, minus 1, minus 2, minus 3. 1, 2, 3. They have given 12 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Ml value is 1 and Ms minus half, as the electron is in downward direction.